Okay, this is exercise 5-1, part 2. In the first video, we graded the street and tied into the existing contours over here. Now we are going to grade the parking lot. So what we've got is 2% slope this way on the road. It comes 2% this way for 10 feet, I think it is. Let me double check that. Yeah, you have 10 feet where it drains towards the street, so it goes into the gutter and then down the street, and then the parking lot drains away from the street and into a catch basin drain inlet down here. So let's go ahead and get started with the parking lot. So instead of trying to locate contours on curves, you just draw a straight line, just a little guideline, and we'll locate spot elevations on these points. It's easier than trying to go around the curve. So with that said, there's a couple ways you can do this. To find this spot elevation right here, this is the 243 contour, so we could just measure from there to there. Other option, you could measure this distance, and get that point and work your way this, you'd go downhill, then you would go downhill this way, then you go uphill to here, 2% down, 2% down, 2% up to get that point. Let's just do it from here. So this is, put my glasses back on. That looks like it is 14 feet. 14 feet from this spot elevation to here. So 14 feet, we know that we don't know what the vertical is, correct? So we're going to go horizontal times slope. Well, what's the slope going this direction? Because we're going, so this is the 2%. So the slope is 2% going this direction. And the distance we said is 14 feet. So 14 times 0.02 equals, calculator here, 14 times 0.02 equals 0.28. So this is elevation 243. This corner here is 243.28. So I'll write that right here, just 243.28. Now, you could calculate on this line from 243.28. We're going downhill now, right? This contour right here, or this slope right here is 2% going that way. So we're going downhill at 2%. So the next whole contour is 243, right? Next whole contour below 243.28. Or the other thing you could do, right, is we came at 2% this way, and we ended up going 10 feet and putting our spot elevation there, and this is going 2%. It's going 2% uphill. Now we're going to go 2% downhill. So you could just continue this line, and this is what I'm going to do, this guideline. Go 10 feet and connect those dots. So there's 243 where it hits the bottom of the curb. Now remember, we're 6 inches lower here than the top of the curb. So if it's 6 inches lower here, we've got to go follow the curb line this direction to get to the top of the curb, just like we did here. Remember, we went back and then we followed the curb line because it's going downhill this way. So think about it. If you have a curb, this is a curb, and you're right here with your contour, this curb sloping downhill, you're going to have to go this direction to keep a flat line, right? You're going to have to go this direction, sloping downhill. So we've got to go from 243, we've got to go to 243.5, right? Because it's a 6-inch curb. We don't know how far we're going to go, but we're going 0.5 feet. And did I write that anywhere? 0.5 feet horizontal. Vertical divided by slope, we're going 0.5 feet at 2%. So that's 25 feet here. So we just measure 25 feet. Right to there. Now we're at the top of the curve. Just like over here, we went 25 feet because it's at 2%. We went 25 feet at 2%. And then now we can find if this is 243 right here, what is the corner here? Let's just go ahead and measure this full distance. We'll just do it from this 243.28. 84, looks like 84 feet. 84 feet. I'm measuring from that spot elevation to there. We don't know what the vertical is, but vertical is horizontal, which we just said is 83 feet. 83 feet. And our slope is 2%. We're going to 83 divided by 0.02 equals, let's see here, 83 divided by 0.02 equals, no, what did I do wrong there? So we're trying to get, not the horizontal, we're trying to get the vertical drop horizontal times slope. What am I thinking? It's early in the morning, so maybe that's why I made that mistake. But vertical, we're trying to find the vertical drop, horizontal times slope. We said it's 83 feet horizontally times the slope, 0.02 or 2%. 83 times 0.02 equals 1.66. So it drops from here, or from here to here, 1.66 feet. So we subtract 1.66 from that elevation. So 243.28, and we subtract 1.66, and we get 241.62 for the bottom of curve. Bottom of curve, 241.62. Now, because we're measuring with a scale on a piece of paper, it's hard to tell. Is that 85 feet or 84 feet? Let's see. So 85 times 0.02 equals 1.7. Just a sec while I check here. 1.7. 241.7862. We're at 241.62. I'm just trying to see if it's 241. If you measure 243.28, 243.28, and I subtract 1.66 equals 241.62. So I'm going to go with 241.62 because I measured 80. Gosh, it's hard to tell. We'll see what happens if we do 83. Now the reason I'm doing this times 0.02 is 1.66. So that's 82. Let's see, 82 times 0.02 equals 82 times 0.02 equals 1.64. So if we take 1.64 from 243, 243.28 minus 1.64 equals 2.64, and if we go 84 times 0.02, I'm just seeing compared to the book, 84 times 0.02 equals 1.68. So if we take 1.68 and subtract it from 243.28 minus 1.68 equals 241.6. Now the reason I just took the time to do that is because I didn't want to confuse you from what the book is. If you measure from the book, they came up with that is 84 feet. And now, you know, so I'm measuring it 84 feet. I get right on there. It looks like it is, 84 feet. So that is the correct distance right there. It was just hard to tell when I was looking at it just on the paper. It's hard to tell. But now that I've got, that's the answer. That's the book answer, which means 84 is correct. I just didn't want you to be confused. If you scaled that off and happen to get 82 or 83 feet and you come off with a slightly different number, that's okay. You're doing it correctly. It's just a measuring discrepancy because, like I said, at 30 scale on a piece of copy paper, sometimes it's hard to scale specifically and see what it is, but I do see that that is probably 84 feet. So 241.6. So we did from here to here 84 feet at 2%. So bottom of curb is 241.6, and top of curb is 6 inches higher. So top of curb is 241.6. You add half a foot to that, 0.5, and you get 242. I'm just going to write top of curb 242.10. So I just added 6 inches to get top of curb there. Here we've got top of curb. So if this is bottom of curb, here is 241.6. Let's find 242. So this is 243 at the bottom, not the top. This is top of curb. So we're working from the bottom, so it's going to be 1 foot. We got to find the next contour. Is this 243? We got to find 242. 242 from this point, bottom of curb, is going to be, it's 1 foot. We're going to find the horizontal, which is vertical divided by slope. So we're going 1 foot vertically divided by 0.02 equals 50 feet. 50 feet. So the next contour is 50 feet away. Oh, wait, 242.1. So this, the top, this is the, oh, I got that wrong. This is bottom of curb here. So 50 feet to the bottom of curb is right here. So this is contour at the bottom of curb. It's easy to get confused or forget, you know, we're working from bottom of curb. You come off of this one, it's top of curb, and then you're messed up. So this is 243, 242, 50 feet apart at the bottom of curb. Now top of curb, this is 243, 242. So top of curb, if this is top of curb 242.1, it's going 2% this way. So 242 is going to come down here and go this direction a certain distance and follow this curb. See how it follows 25 feet? Well, we don't have 25 feet here. So we've got to go 242.1. We've got to go vertically down 0.1 feet to 242. And so that's 0.1. And we're trying to find the horizontal, divided by 0.02, which is the slope, right, going this way. 0.1 divided by 0.02 equals 5 feet. So we'll draw this 5 feet here, and that's where 242 at the top of curb goes. So 242 will run along the curb to right here, and then 242 is going to have to tie back in to 242 here. Now this 242 is at the bottom, so we've got to come across over to this side. But before we do that, let's just go ahead and tie these two contours in. So this is 243, and it's going to just tie in to 243. 242 is going to have to come around like that and tie into 242. Let's figure out where 243 falls on this side over here. Well, we know that this is 243 here, so draw a perpendicular line. This is where it's going to fall over here. So this is 243. So if we come straight across, this is going 2%. This is 243, and this is a 24-foot driveway. So what is the elevation right here? If this is 243 and it's 24 feet dropping at 2%, it's still going 2%, right? 2% this direction. Then it's 24 feet horizontally. We're trying to find what the vertical is. 24 feet times 0.02, which is a slope. So we're going 24 feet at 2%, because see, everything's going 2% this way. 24 times 0.02 equals 0.48. So it drops almost a half a foot across here. So this would be 240, 243 minus, whoops, what did I say? 24 times 0.02 equals 0.48 feet. So it drops 0.48 from here to here. And that is 243 minus 0.48 equals 242.52. So right there is 242.52. Other thing is we have this here, 243.28. So you could do the same thing, draw a guideline here and come straight down, and that would be 24 feet at 2%, and you can get the elevation right here. I went ahead and just drew a perpendicular line along this, and that's how I located it. You could do the same thing here. It might be more accurate because you have this straight line, so you'd know exactly where it is, but that's, I just came across and did that. So now we've got to go 242.52. we got to go half a foot, right, or 0.52 feet at 2% that way to get to 242. So we'll go 0.52 feet, right? We got to drop 0.52 feet to get to the 242 contour. And to get the horizontal distance, we divide that by the slope. And what's that equal? 0.52 divided by 0.02 equals 26 feet. So if we measure 26 feet right there, that's where, measure 26 feet, that's where contour 242 hits. So now we can connect these like that. So this is 242, 243, and you'll notice that the contours are parallel, which they will be because it's all a even slope of 2%. So those are those two contours are parallel, and you'll see that these contours are going to be parallel as well. So if this is, let's go ahead and find this corner here first before we go any further. The way you do that is just draw a line straight across, and we know that the bottom of curb right here is 241.6, and this is, I mean, it looks like 47 feet to me. 47 feet, which, you look over here, you basically have 24 feet, and then looks like, man, it's so hard to tell how close, but almost like 14 feet. So 24 and 14, 24. Just checking to see, since it's, so that I get 38 feet from there to that corner, which would be the same here, 38 feet. Yeah, because I get 38 feet. So let's do 38 feet. So to this point right here, that is going to be 38 feet at 2%, right? And we don't know what the vertical drop is. So vertical, again, is horizontal times slope. So it's 38 feet horizontally times 0.02, which is 2%. 38 times 0.02 equals 0.76. So it drops 0.76 down to there. So let's go ahead and subtract that from the bottom of curb. 241.6 minus 0.76 equals 240.84. So this is 240.84. Now, from here, it's going 2%, right? Everything's flowing 2% this way. So now it's easy to get this elevation. It's just 60 feet. 60 feet at 2%. So 60 feet times 0.02 equals 60 times 0.02 equals 1.2 feet. So it goes uphill 1.2 feet to that point. So let's add 1.2 to 240.84. 240.84 plus 1.2. 142.04 or 242.04. So bottom curb 242 point, let me make that a little bigger so you guys can read it, hopefully. Bottom of curve 242.04. Bottom of curve is 240, so 242.04. Top curb is just going to be half a foot higher, right? So 242.09. I just added 0.5 to 0.0, or not point, 242 point. Wait, did I add that right? Let me see if I wrote that down. 240.84. 240.84 plus 1.2 plus 1.2, 242.04. Okay, that's correct. Plus 0.5, 242.54. So I just added a half a foot to the bottom of curve right there to get the top of curve. Now let's get this top of curve and bottom of curve down here. Top of curve, bottom of curve. And this is, looks like 62 feet. So, just looking, actually 63 feet. 63. I scaled that off. You guys check that? I check in a little bit better light and it looks like 63. So it's 63, I can write here, 63 feet times, it's going downhill at 2%, 0.02, because we're trying to find the vertical drop, right? And vertical is right here. Horizontal times scale, or times slope. 63 times 0.02 equals 1.26. 1.26 feet. So it's dropping 1.26 feet from here to here. So we'll go bottom of curve first, and we'll just subtract 242.04 minus 1.26. 1.26 equals 240.78. So bottom of curve is 240. Oops, wrote that wrong. 240.78. 240.78. Just add a half a foot to that. plus 0.5 equals 241.28, and that's your top of curb, 241.28. So we measured this one and got this elevation right here. Then we just added half a foot to get top of curb because it's a 6-inch curb. And now, what else should we do? Now we can do, well, we can figure out where 240, if this, remember, we're going to work from bottom of curb to this, let's work down this curb line. So bottom of curb here is 241.6, so we got to get to 241. So we're going to go 0.6 feet vertically, 0.6, 0.6. I'm going to make sure my arm stays, I want to make sure this is still 0.6 is our vertical. We're trying to figure out what the horizontal is, which is vertical divided by the slope, which is 0.02. So 0.6 divided by 0.02 equals 30 feet. So bottom of curb, we're going to go 30 feet from this corner. And that is where we get, so that's 241 bottom of curb. So 241 bottom of curb, where's 241 over here bottom of curb? Well, bottom of curb is 242.404 here, so, and it's 240.78 here, so we know it's somewhere in between here. Bottom of curb, 242.04. So we're going to go let's go to bottom of curb. Let's find, first we'll find 242, right? Because it's 242.04, so we got to come 0.04 vertically. We got to drop 0.04 feet to get 242 contour on here. So how far is it from this corner? We're looking for the horizontal distance. That's this one here. Vertical, right? 0.04. I want to make sure I don't run out of room. Just watch my 0.04. And that's, we're trying to find the horizontal distance, and we divide that by 0.02. 0.04 divided by bottom of curb. Actually, no, sorry. We're trying to find top of curb because 242 bottom of curb is right there. So top of curb is 240. So it's going to be running along this curb line. So top of curb, we got to find where 242 hits the top of curb because bottom of curb is right there. So with that being the case, we got to go 242.54, and we've got to go top of curb. So where's the top of curb? Where's 242 lie? 0.54 feet vertically away. So let's do that. 0.54. And to get vertical, it's, or to get horizontal, it's vertical, 0.54 divided by 0.02 equals 0.54 divided by 0.02 equals 27 feet. So based on that, this is top of curb, 27 feet away, and I gotta go 27 feet. That's where 242 comes around the front face of this curb all the way to here. So now we're at the top of curb right here for 242. It's following the face of the curb, and then it's got to tie in over here. And in the instructions they say to make it a little bit of a mini ridge. So a mini ridge, it's going to have a little bit of an arc like that. So the ridge, because remember going downhill, it's going 2% this way. That's a ridge. If it was curved this way, it would be kind of a basin. So I just created a little ridge, and then this goes all the way around. This contour goes all the way around like that. Now we got to find where 240 contour 241. This is 240, so now we got 241. Where 241 hits at the bottom of the curve here, right? Because now we're working. This is 241 at the bottom of the curve. Where's 241 over here at the bottom of the curve? Well, bottom of curve is 240.78. So staying with the bottom of the curve to get to 241 at the bottom of the curve here, it's 240.78. It's so 241 minus 240.78. What do we get? Minus 240.78. 22 feet, 0.22 feet away. So we have to add, it's vertically 0.22 feet away to get to 240. So we're trying to find the horizontal distance. So it's 0.22, and we divide that by the slope, which is 0.2, and we get 0.22 divided by 0.02 equals 11 feet. So that equals 11 feet. So we have to go 11 feet from here, this direction, right? Because the bottom of curve is lower than 241. We got to go 11 feet this direction to get to 241, which puts it right there. So we can connect 241 bottom of curve to 241 bottom of curve. And there you go. You get, see how their lines are parallel? So you know you're doing the right thing if your contours stay parallel. So that's 241. Now, if this is 241 bottom of curve here, we got to go up. This is bottom of curve, so this is, where would 241 bottom of curve, 241 bottom of curve, we got to find where 241 lands on the top of curve. So let's look here, 240, top of curve, 241.28, right there, top of curve. So 241 is going to be from there a certain horizontal distance. We don't know what that is. Horizontal is vertical. So to get 241, we got to drop 0.28 feet, right? So 0.28, and divide that by the slope, which is 0.02, right? Because your slope right there, they say your slope is 2%. All of this is 2%. So it's going this direction, downhill at 2%, 0.28, top of curve, divided by 0.02, 0.28 divided by 0.28. Where did I write that down? Lost my spot. 0.28 divided by 0.02 right here. Divided by 0.02 equals 14 feet. So just measure 14 feet. 14 feet gets you right to here, right to there. So that is, we went from top of curb. Did I go 0.28? Did I write that right? 0.28? Yeah, top of curb. We went 14 feet to get to, yeah, top of curb. We used top of curb here, 2%, and we went 14 feet to get 241. So that means this contour follows like that. So the contour goes around, and that's where it hits the top of curve. Now, if this is 241 here at the bottom of curve, it's 241.5 would be top of curve, right? At this point right here. So we could, if we need to go, if that's 241.5 at the top of curve, we need to go 0.5 feet vertically this direction. We'll do, think about the top of curve. 241 at the bottom of the curve. Top of curve right here is 241.5. So now let's forget about everything else. Just know that you're at 241.5 top of curve, going this direction at 2%. So we've got to figure out how far it is downhill, if this is 241.5, downhill to get to 241, which is 0.5 feet away vertically, and the slope is still that 2%. They make it pretty easy with that part, so 0.5 divided by 0.02 equals 25 feet. 25 feet, so just measure 25 feet. That's where 241 follows this front face of curb to get to the top of curb right here. So now you can just come here, and that connects. There's actually a little, it comes off just a little from the curb, and then connect right here. So I just did 241, 242. All right. Next, let me see here. We're gonna do, let me check my, yeah, let's go ahead here. Let me check something real quick. Just have to, check some, sorry for the, I gotta check my calendar. So 8:37. All right, this is, we're going to end part 2 here. We're going to finish part 3 because I've got a meeting I have to go to. So I'm going to stop the video, and then we'll finish part 3 when I get back from my meeting, and grade the rest of this parking lot into this catch basin here. So we will end up with 3 parts to this video.